Everyone. So today we are going to do a tutorial using smart template for PSC beam bridge. So the previous bridge is using the PSC, so pre-stressed concrete box of a bridge, but this one it is using a array or a compilation of I girder. And this compilation of I girder will be connected using rigid link. Okay, so this specification of the beam bridge will be a beam bridge with a total length of 30.2 meter, with a width of 18 meter, slab height of 0.24 meter, girder length of 29.9 meter, with a height of 1.5 meter, with a spacing of 2.5 meter. The number of girder is 7 for each span. Okay, we can just go ahead and start using the smart template. So first thing first is to click the smart template and click on the PSC beam bridge here. Okay, and just click layout to see the either support 1 and support 2. So as you can see, you can change the value of the support, but in this case, as you can see, the span length is 30.2 with a girder length of 29.9, with a bearing location of 0.4 in here. So all of this value is can be seen in this guide. Okay, and in this case, in this beam bridge, there is no advanced method like the one that we have covered before in the FCM bridge. So there's no advanced method, so this is just as simple as this one. We can also change the number of span if we want to add another span. And in terms of the model tab creation, there is a lot of choices. Okay, we can also consider the bridge widening if there is a tapered section. So if, for example, the first section of the bridge is smaller than the end point of the bridge, so you can change the consider bridge widening, or the other way around. So it is applicable if you have a different section in your start and end point. But in this case, we only want to create a similar section area. Okay, so after seeing all of this, you can just click to create assembly unit. Okay, so this is the assembly unit, and you can just click apply and exit, and then you want to click to create layout. Okay, And in this case, because you only have one span, it means that you just needed to create one with the name of PSC beam layout. You just need to create a straight with a length of 30.2 meter with a vertical alignment of station 30.2 as well, with the elevation of 0, so there is no elevation at all, with a similar segment and super elevation, and you can just click apply. Okay, and the next one is to just assign the assembly. Similar to last one, just click on assembly and click assign, and click on the whole layout, select layout, and then add. Okay, if you are you can just click on preview if you want to see. As you can see here, this is the preview of the model, and you can just click apply and close. Okay, so to see the beam bridge, you can just click on view and click transparency 0.5 maybe. Okay, as you can see, this bridge contains a lot of eye girder. Okay, and we want to create the rigid link for each of the beam bridge. Just click on the front, and maybe you want to isolate just the one of the beam bridge. You can do so by clicking. Okay, so in this case, we can see the top side. Okay, and we want to be able to insert the rigid link. Okay, and the rigid link will be vertex to 1D member with a master point of 1D member. So the vertex will be starting from the this point. So the vertex will be from this point until this point. So okay, and then for the 1D member, it will be the member from in which this one is on. Okay, so this part. Okay, but in this case it will be 7, I would think. 2, 3, 4, 5, 6, 7. Okay. The master point will be 1D member with the degree of freedom of rigid. Okay. And it is similar to the next two part. Okay. From here, Okay, wait. Okay, this one 12, and the one member will be this part. One, two, three, 4, 5, 6, 7. Master point of one member. Okay, and the last one will be similar. Okay, 12 with the one member of 1, 2, 3, 4, 5, 6, 7. Okay. 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 As you can see, after I activate the the bearing here, when you see at the left side, okay, you can assign the rigid link for the second time for the vertex 1D member. So the vertex will be this one. So from this side to this side. As you can see, this is slightly wrong because we just want to add the slightest part. Okay. Okay, so as you can see, we just want to add the top side. Okay, and for the 1D member, we will be clicking on, similar to last one, it's just the boxes. As you can see in the top and side, you can click on the 1D member and you can click on the boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And then the master point will be one member, rigid link, and apply. So as you can see, we will have the 50 rigid link in here. And we go ahead with the elastic link for the support. Okay. You can go to left and click show all. And then click on the bearing and click show only. And as you can see, we can just click on boundary and click on elastic and click on start and click on end with the stiffness of kilonewton meter, 3,270,000, 1,801, 1,801. Okay, apply, and we do similar things. Apply, Okay. Okay, now moving on to the support. You can click on boundary support and select target. The target will be the bottom part. Don't forget, you just have to click on the bottom part. So this is quite tricky. Okay. You may have to click on one by one just to be safe. Okay, 14. Apply and close. And then just right click and show all. And then you want to define the composite slab. The slab up top from your bridge. You want to just click on this part, show only. Okay. And in the left hand side, you can see that in this part, you can just show this selected, and it showed you the only the slab. And after that, you can just click on the composite in the analysis part here. And then for the target, you can click all of them. Okay. And you don't have to click on the template section and the assign user section because it's already because you want to create the composite slab, the plate on top of the beam is not tapered because the area in the start point is similar to the area in the end point. Okay, and you can change the width to 2.5 meter, the thickness of 0.24, the offset of Z of 0.12 meter. Okay, and then apply and close. And then just right click and show all. You can see the composite is already there. This one is the composite. Okay, and we can just go ahead to create the analysis case to be imported to the Midas Civil. You can click define. Okay, and you can change the analysis case to composite interface with the 1D element of all of them, except the plate element, of course. 1D element of all of them except the plate element, of course. Okay. For the boundary condition, you can select all of them. And for the mesh size of the 1D element, you can go with the length of 1 meter and apply and close. Okay. After that, you can just click OK and click on Midas Civil, run Midas Civil NX with the Composite interface, and click OK. As you can see, you can check all of them, the section and the rigid link, etc. is already there, which is good. Okay, so that's all the thing that we can go so far. So thank you. I will see you next time. Okay, thank you.